Hey guys, in this video I want to go ahead and talk about residual plots. En este video quiero hablar de los residuos y las parcelas de los residuales. Um, Guys, so in this video we're going to talk about a little bit of statistics. It's just basic to Algebra 1 and it stems from the line of best fit. Okay, so if you notice we have the line of best fit right here. And we want to make sure that we get the best line possible. So you see how this line, you got to try to fit it in between these points so that the distance between this point and the line is as minimal as possible. Because you can draw the line up here, but then these points are way off. And you can make the line over here, but then it still would be way off. And you don't want that. So you want to minimize the distance from this point to the line. That's your predicted line. That's your line of best fit. Okay. Entonces, muchachos, cuando están haciendo esta línea, la línea que tiene que incluir todos estos puntos, okay, queremos una línea que esté lo mínimo de distancia de estos puntos. Puedo hacer la línea acá, pero la línea va a ser muy ancha y la distancia de estos puntos va a ser muy grande. Okay, entonces quiero construir una línea que esté casi incluyendo todos estos valores, pero que sea lo mínimo de este punto a la línea. So guys, I want to make sure that the distance from this point to this line here is as minimal as possible. That'll make sure that I have the best line, the best fit line for my model or my prediction. And the distance between this point or the point and the line, the actual predicted line, the line of best fit, is called the residual. And the residual, guys, is the observed value minus the predicted. Well, what does that mean? Well, a lot of times you can have a line of best fit. You can have the equation, right? Well, this equation predicts the values based on the points that they give me. Okay, so we have an example here, and this is the age in months of babies, and this is their height in centimeters. Okay, so based on this model, okay, a baby that's 16 months old should give me a predicted centimeter height. Well, these are the observed heights, okay? So these are observed. So the distance, because these all points don't fit on that line. So what I do, the observed value, okay, is what? 73 centimeters, okay? That's the observed value. That's the measurement. That's the actual measurement that I got. But based on my equation, when I plug it in, I get 74.86. That's what the line predicts. So when I take the actual value, what I observed minus the predicted, this is the leftover. This is the residual. Okay, and that's what I would use to plot. And I want to minimize that as much as possible to make sure that my model is predicting or is an accurate prediction of what I'm talking about. Entonces, lo que estoy diciendo, muchachos, es cuando estamos hablando de los residuales, que esta ecuación predica los centímetros de estos bebés. Okay, entonces esta línea, esta ecuación con un bebé que tiene 16 meses, okay, me va diciendo que va a medir 74 centímetros, pero actualmente me sale que mide 73. Entonces la diferencia entre el valor observado y el valor predicho, okay, es el residual, el residuo. Entonces, cuando yo resto esto, el 73 menos lo que me dice la ecuación que agarré, okay, ¿qué es esto? Eso es el residual, el residuo. Okay, so guys, why is the residual very important? Because it tells me if my graph, if my model is correct, because there are different types of models. There's linear, there's quadratic, there's cubic, there's logarithmic, there's different models. And we want to make sure that our model fits our data, okay? Because the better it fits, that means it's going to be a correct predictor of the information. Entonces, lo importante de los residuos es porque usando los residuos me va a decir si mi modelo que estoy usando de línea cae bien con la información que me da. Porque hay muchos diferentes modelos. Hay modelos cuadráticos, logarítmicos, hay modelos cúbicos, entonces hay todos diferentes. So then how do we decide, if my model is correct? Well, you look at the residual graph or the residual plot. So these are residuals, okay? These are the points here that I use to graph, okay? The difference. And what you want to do, once you get these values here, your predicted, your observed value minus your predicted, that's all these little points here. Todos estos puntos aquí son este valor, el valor observado menos el valor predicho, okay? El valor que la ecuación me dice que tengo que sacar, okay? Entonces hago la gráfica aquí. And what you want to see, guys, is an equal disbursement, top and bottom, of the points. And that tells me that it's well balanced and that the graph, the model, is correct in using a linear model for this data. Because sometimes you'll get different residual plots. You see this guy right here? It looks like a U shape. So this would not be a good model for a linear. It would be a good model for a quadratic regression line. Este no es un modelo bueno para una línea. Es mejor que se use un modelo cuadrático. This guy, you see how it's evenly spread out? This guy would be linear as well. Este modelo sería usar linear. Y después this guy, also another quadratic. Okay? So that's why we use residual plots in order to determine if our line is a good model or is a good fit for this data. Sometimes it is, sometimes it's not. Okay, guys? So once again, how do you figure out the residual? You take the observed value. That's the actual value that they give you. This is what was measured. Es lo que se medió. Minus the predicted. Well, where do you get your predicted value from? Well, you take this guy, you put it in your equation. This is your line of best fit. This is your equation that's going to predict the value. So for a 16-month-old baby, it predicts that it should be 74 centimeters. Okay, well, the actual observed value is 73. The actual predicted was 74,863. When I subtract that, that gives me negative 1.863. That's the residual. Same thing with a 19-month-old. Okay, what was observed? Well, the actual value is 76. Okay, minus, well, what's the predicted? Okay, the predicted was, plug in the 19, and what do I get? 76.747. When I subtract that, I get this guy as my residual. And see, these are the points that I would plot here. Okay, some would be negative, some would be positive. But I want an evenly dispersed set of residual plots, so that way I know that my model fits a linear model. Okay, so hopefully that makes sense. And keep working hard, guys. I'll see you guys next time.